Saxon Advanced Mathematics, Lesson 35. Greetings, students. We have 3 topics in this lesson, but they all flow together. They're kind of connected. So I will break them apart, but put your mind in the place of seeing that these are all connected. Okay, the first thing we want to talk about is what happens when we're changing coordinates, and eventually what we're going to be doing is measuring the distance between 2 coordinates, and we're going to build up to that. The first thing we want to talk about is how you measure that change in coordinates. Okay, so here are 2 coordinates, and we want to measure the change in coordinates, not the distance, but the change in the coordinates. The way that we do that is fairly simple. We always take the final coordinate and subtract from it the initial coordinate. And we do that for the x's and the y's separately, but we always start with the end, so to speak, right? We start with the final and we go to the initial, which means that the direction that we're going matters as well as the distance. So what I'm going to do is I'm going to call this, I'm going to just choose some random letters. I'm going to call this one F and this one G. All right. If we're going from point F to point G, that means that F is the initial place and G is the final. So for our x coordinates, we want to do final minus initial, right? So we're setting up our calculation and in the opposite order of our flow. So our final x value would be 3, and then we would subtract our initial f value, which is minus 7. So we would find that the change in x, would be a positive 10. I'm just going to squeeze that positive in. You'll see why later. And then for y, as we move in this direction from F to G, that means minus 2 minus positive 4, right? And so this would be negative 6. That's the change in our y coordinates as we move in this direction. But what happens if we take the very same points and say, let's go in the opposite direction? We want to go this time from G to F. So we're using the same pairs of points, but this time G is the initial and F is the final. So our calculations are going to be reversed, aren't they? For x, the final position is the F position. It's minus 7. And then we would subtract the G position, which is 3. So now the change in our x value is minus 10. And let's just check out the y. Y, we're starting with F as our final, so that would be positive 4. And then we're subtracting the G position for Y, which is minus 2. So that's 4 plus 2, so that's a positive 6 is the change in Y. So what we see, if we compare these two, is we see that going from here to here versus going from here to here, it's the same number, right? The change is the same, which makes sense because we're just going from one point to the other and back again, but the sign changes, all right? So that's important, and we're going to come back to that idea at the very end of this lesson. Now, let's look at the examples that John is throwing us. example 35.1. Given the points, and John insists on using subscripts, which I think make it even more confusing. -3, 2, and P2, which is -4, 5. He says, what do we represent by this? And what do we represent by this? Okay, so let's look at the values. Okay, I see that this is measuring, these has got X values. So we're measuring in this the change in X. Whoops, change in X, right? It's the X rather than the Y, right? This is X, this is Y, just to keep our heads on straight. And we know that it's always final minus initial. Let me make that look like an I. So this is the final point, and this is the initial point. So that means we're moving from P2 to P1, right? Because we always list the final point first, and that's this one, okay? Let's check out this one. This is the change in the Y, isn't it? Because these are the Y values. And again, final is first in this expression. So that means P2. So in this one, we're going from P1 to P2. And I'm just double checking. And this is what John says for the answer. Expression A represents the change in the X coordinate when we move from P2 to P1. He writes it out as a big sentence. You don't need to do that. And B represents the change in the Y coordinate as we move from P1 to P2. Okay, so you don't have to write out a big sentence. Just notice which variable is changing and which direction we're moving, if those are the 2 points. Okay, and then another problem that's very similar. I feel like my green marker is giving up the ghost. If the coordinates of P1 are -3, -2, and the coordinates of P2, I'm sorry, I always just say it out loud to myself and I'm not sure why. Okay, so this is the same kind of problem. What do we represent by -4, -3? And then part B is -2, okay? We know that these are the X's again. I can just write this in, and Y. Just helps keep things straight. We know that it's final minus initial. So this tells us that this is the final point. Okay, so it's the change in X. We can see that right away, right? The 3 and the 4. -3 and -4. Change in X. And this is the final point. And that's the initial. So we're going from P1 to P2. Right? It's confusing because we have to follow this, but they're always reversed here. We always start with the final and end with the initial. So the final is P2. So then I write it this way. It's confusing. All right, and then -2 would be the final. So this is P2 to P1. And it's the change in the Y value. Double checking the answer. X from P1 to P2. And this is the change in Y, P2 to P1. Yay, we got all this right. All right, so this is just how we measure the change in coordinates, and it's a very simple idea. We take the ending place, the final, and we subtract the initial. Okay, so what's another way we can use this problem